Hello and welcome to question 2 of our walkthrough of level 3 integration exam. Let's get started on question A, which is find the integral of e to the power of 4x minus 6 over x squared with respect to x. So the first thing I'm going to do is rewrite that second part as 6x to the power of negative 2. So no natural log used here because it's not x to the power of 1 down the bottom. It was an x squared, so we're going to rewrite it like that and then integrate in the normal way. So for the e to the power of x, need to think about chain rule, as in differentiating but in reverse. So the integral of e to the power of 4x is e to the power of 4x. And then we divide by the derivative of the power, which would be 4. So we'll go over 4. And then for the next one, let's add 1 to the power and divide by the new power and then the plus c. And we'll just simplify that. Again, I prefer mine written like this, but it doesn't really matter. That first bit hasn't really changed. And then now just change that to plus. We'll just go 6 over x and then plus c. It would have been okay to leave it as 6x to the power of negative 1. I think that just looks a bit nicer. And that is the answer for that one. So that is an achieved question. Okay, on to part B then. Use the values in the table below to find an approximation to the integral between 0 and 2 of f of x. And we've been given a table there and we've been told to use Simpson's rule. So you have a formula for Simpson's rule on your formula sheet. It is on the third page, all the way down at the bottom. It's quite complicated, but the first thing we want to do is work out h. So that is the jump each time in the x values. So you can probably tell that that is 0.5. So that is h. Then I'm just going to label these. So this one is y0, y1, y2, y3, and y4. So we're going to go area equals 1/3 and then 0.5, so 1/3 h, and then it's y0, so 3.6, plus yn, so that is your last one, so that will be 3.9 for us, plus 4 times y1, y3, so all the odd numbers, all the odd numbered y's, so that's 4.4 plus 4.7 in our case, and then plus 2 of all the even y's, so that'll be just y2 for us. And we'll work out what that gives us. And what that gives us is 9.0166667, which I think we can just call 9.02. There's no units for that, so that is just the answer. And that is another achieved question. Okay, on to question C. Find k so that the integral from 1 to k of 4 square root 3x plus 1 dx equals 448 over 9. So to start off with, we need to integrate. Well, first thing I'm going to do, before I can do that, is rewrite this like this, so as a power of 1/2. Over 9. Okay, now I'm going to integrate it. So we've got to think kind of chain rule again in reverse here. So we are going to have 3x plus 1. So add 1 to the power is 3 over 2. Then we divide by that and by the derivative of what's in here. So we're going to have 4 divided by the new power of 3 over 2 and then divided by 3. So I'll just write all that as division just to make it clear what's happening there. And then all of that is between 1 and k equals 448 over 9. So all of that simplifies to 8 over 9. And then 3x plus 1 to the power of 3 over 2. And k1 is 448 over 9. So now we're going to work out the definite integral. So biggest value first, which is k. So I'm going to go 8 over 9, 3k plus 1 to the power of 3 over 2. Take away 8 over 9. 3 times 1, so just substituting in those values. So all of this should equal 448 over 9. This whole thing here, just calculate, that's all numbers, so we can calculate that. That comes out to 64 over 9. And for the first one, not really an awful lot we can do with that at the moment. So it all equals 448 over 9. So now what we are going to do is we can take that 64 over 9 to the other side and just add that to both sides. So just going through a process to get k by itself, which we will get there eventually. So just going through a process of getting k by itself, which we will eventually get there. So that makes 512 over 9. I'll just go up here now. Divide both sides by 8 over 9. And that will make 64 on this side. Then do both sides to the power of 2/3, which will just undo this power here. Or if you want to think about it as so squaring it and then cube rooting it. Either way, we're removing that power from those brackets on that side, and that leaves us with 16 on this side. Don't really need those brackets now. Let's just get rid of those. They're not doing anything now. And then take away 1 from both sides, and then divide both sides by 3. And that gives us an answer that k equals 5, which is what we wanted, find k. So we got there. So for achieved on this question, correct integration. So that happened quite a long time ago. Where is it? We integrated here. Okay, all the way back there is achieved. And then quite a lot of extra work to get to the merit. If dy over dx equals cubed root of y times sine 8x and y equals 1 when x equals pi over 8, find the value of y when x equals pi. So to begin with, this is a bit of a mess. We've got x's and y's and stuff on both sides. This is a differential equation. So we need to start by getting all the y's on one side and then getting all the x's on the other side. So I will begin by multiplying both sides by dx. So dy equals the cubed root of y times sine 8x dx. Then divide both sides by the cubed root of y. So that will be 1 over the cubed root of y dy equals sine 8x dx. Okay, still quite messy, but that looks a lot better. We've got x's on the right and y's on the left. So before I can integrate the left-hand side, need to just rewrite that as negative power. So that's the 1 over the cubed root of y. So that would be y to the power of negative 1/3. And that will then allow us to integrate that. Now we integrate both sides. So add 1 to the power is 2/3, divide by the power, plus C1. We're going to get a constant of integration on both sides. So plus C2. So that's why I'm calling them C1 and C2. With the sine 8x, so sine integrates to cos. And then just remember we've got to divide by the derivative of the argument inside it. So the derivative of 8x is 8. So that's why it got divided. And it's now negative because sine x integrates to negative cos x. So this looks like a bit of a mess still. So let's tidy things up a little bit. Being divided by 2/3 is the same as being times by 3 over 2. So 3 over 2 y to the power of 2 over 3 equals negative 1 over 8 cos 8x. So we can just put those c's together and just go plus c. So that looks a lot nicer now. So let's just reread the question, make sure we're answering it. If dy over dx equals cubed root of y times sine 8x and y equals 1 when x equals pi over 8, find the value of y when x equals pi. So to do that, to find y when x equals pi, we need to find this c, which is why we've been told when x is pi over 8, y is 1. So if we substitute pi over 8 for x and 1 for y, that will leave c as the only unknown, meaning we can solve it and find it. So we will just simplify a little bit. You could just do all this in the calculator in one go. 1 to the power 2/3 would just be 1, then times by 3 over 2 would be 3 over 2. So plus 1 over 8 cos of, 8 times pi over 8 would be pi. That equals c, and c comes out at 11 over 8. Meaning that our equation is 3 over 2 y to the power of 2 over 3 equals negative 1 over 8 cos 8x plus 11 over 8. And now we can use that to find the value of y when x equals pi. So I'll just do this in a different card to make it clear what's happening. So we're going to substitute 8 pi for x, and then we're going to work out y. So 3, nothing's going to happen on that side. So y, sorry. So let's just recheck the question. If dy over dx equals cubed root of y times sine 8x and y equals 1 when x equals pi over 8, find the value of y when x equals pi. So x equals pi, now we can find y now that we've found the plus c. So let's substitute x equals pi into the equation, and then we'll see what we've got, and then we can start solving for y. -1/8 cos 8 pi plus 11/8. So we can work out what we get on the whole of that side, because that's all numbers, and that is 5/4. So 3/2 pi y to the power 2/3 equals 5/4. So y to the power of 2/3 then will equal 5/6. So just dividing both sides by 3/2. And then a bit similar to what we did before, we could now, you can think of this as cube it and then square root it. Either way, it's going to end up doing this. To do both sides to the power of 3/2 is the same thing. And that comes out to 0.7607257774, which I think we can just round to 0.7607. So that is a merit question to do that. So for achieved, a correct integration of either side, that all happened quite a long time ago. So correct integration of either side, so that would be sort of getting here. And then merit correct solution with correct integrals all the way down here for the merit. Question E now. The graph shows the curve y equals e to the power of half x take away 2 plus x minus 4.99. Find the shaded area. So we're looking for this yellow shaded area. Now you'll notice some of it is above the x-axis and some of it is below the x-axis. And that is a problem in terms of doing the definite integral. So we've got to get around that problem, and we can do that by working out the two shaded areas separately. And then we're going to take the absolute value of that bottom one here, because that will come out negative. So I'll just make a note that we're going to do the absolute value of there. So it is positive. So we work out those two sections separately. So what we need to do then is find this point here. Now we know at that point x equals, well, we don't know what x equals, that's what we need to find, but we do know that y equals 0 because we are on the x-axis. So what we're going to do is substitute that into the equation and solve for x. Now, to save all of us a bit of time, I'm just going to put that in the calculator, and that comes out to x equals 4. So it did look like it was going to be 4 on the graph, but we just wanted to make sure. So now we are going to work out the area. So like I mentioned before, we're going to take the absolute value of the integral between 0 and 4. And then e to the power of half x take away 2 plus x take away 4.99. And then plus the integral between 4 and 10 of the same thing. So we're going to work out those two bits separately. So we'll integrate. And that will give us 2e to the power of half x take away 2 plus x squared over 2 take away 4.99x. So again, we're going to want the absolute value of that, so between 0 and 4. Keeping that there just to remind us, we don't want to forget to do that. And then this bit is going to be, well, pretty similar. In fact, it's going to be, obviously, we'll integrate to exactly the same thing. But this one, the boundaries are different. That's going to be between 4 and 10. So now we're going to have a bit of a time jump. Okay, it is now the following day, and I have written all of that in. So just substituted the 4, the 0, then the 10, the 4 into the definite integral, used an absolute ton of brackets to make sure everything stays separated. And I have got the first stage of working it out down the bottom here. Still got my absolute value. And you see this is going to come out negative, so that is important that I've got that. I've just worked out what each bit is. So on the calculator, I did each of these 4 sections separately. So if this is one section here, this is one section here, one here, and one here, I worked out those 4 all separately on the calculator to get these answers that you see in this last line of working. And now when we are nearly there, thankfully. So this first bit comes out at 10.1706757. I will round this afterwards. Plus 50.23107385. So that is 60.40174442, which will go 2 decimal places, 60.40. And that is the answer. That is the area under the curve. So for achieved, we need a correct integral. So that is getting to here. For merit, setting up all of this nonsense here. And then for excellence, getting the answer for the area. And that concludes question 2. Thank you for watching.